Hi, everyone. In the last couple lectures, I really emphasized the notion of validity as a central notion that we will capture with our formal deductive logic. This is certainly true, and it's very important that you get a strong intuitive grasp on what the notion of validity is, so that when we start developing our formal tools, you will understand what it is that we're trying to do with those formal tools. So again, it's certainly true that validity is the central notion that we will try to capture. However, in addition to validity, there are several other logical notions which we will be able to capture with our logic. So the purpose of this lecture is to go over some definitions of some additional logical notions that we will eventually be able to understand precisely with our formal logic, which we will begin developing uh, next at the beginning of next week. So here we go. There are two broad parts to this lecture. First, I'm going to talk about some logical notions that relate to individual statements, and this has to do with different ways in which statements can be true or false. But in addition to these logical notions that apply just to statements, there's also logical notions that apply to groups of statements. And so in the second part of this lecture, we will talk about some logical notions that apply to groups of statements. So as review, recall that statements are sentences that can be either true or false. Statements are the basic units of logical analysis. So here is a simple example of a statement. Snow is white. This simple sentence, snow is white, makes a claim about the way things are, and this claim can be either true or false. And it's precisely sentences like this which will be the ones we use in our logic. Sentences that make claims about the way that things are. And it's crucial to understand that not all sentences are statements, so not all sentences make claims that can be either true or false. So a simple example is the question, what time is it? That question or that interrogative sentence doesn't make a claim about the way things are, rather it asks about the way that things are. So there are many examples of sentences that we will not be applying our logic to understanding. Rather, our logic will help us understand some simple declarative sentences or statements, ones that make claims about the way things are, and hence ones that can be either true or false. So what do we mean by truth? So in our logic, we will assume that all statements are either true or false, and never both. So that is to say that we will assume for the purposes of our logic that any statement whatsoever is either true or false, and never both. Another way of putting this is that we assume that every statement has a truth value, or has exactly one truth value. And the two truth values are as follows: true and false. So that is to say that every statement is either true or it's false. Now, it's also important to understand that when we talk about the truth value of a statement or proposition, we're talking about something objective. So whether a statement is true or false in some situation does not depend on what anyone thinks. So to return to our simple example, whether or not it's true that snow is white doesn't depend on whether we might believe it's white or not. Rather, what makes this sentence "snow is white" true is an objective aspect of reality. And so that means that when we talk about statements being either true or false, that is something different than whether we believe they're true or false, or Rather, it has to do with the way things objectively are in reality. And we assume that the way that things objectively are in reality is such that every statement is either true or false, and never both true and false. So this is an important assumption for how we're understanding the truth of statements when we apply our logic. So now we can turn to different ways in which statements can be true. So these three notions are under the broad heading of actuality, possibility, and necessity. So first, hopefully it's obvious that some statements are actually true. So the statement from earlier, that snow is white, that statement is in fact true. But there's also, of course, many statements which are not. There's many statements which are false. So here's an example of a statement which is false. Al Gore was president of the United States in 2007. When I utter that sentence, I'm making a statement which is false. I'm saying something false. Okay, so a statement, there are many cases of statements which are true and many cases of them which are false. However, in addition to the actual truth and falsity of statements, we can talk about their possible truth or falsity. So some statements that are not actually true, i.e. some statements that are false, can still be possibly true. So for instance, Al Gore was not actually president in 2007, but he might have been. That is to say, it's possibly true that Al Gore was president in 2007. That is something that's possible. So in addition to whether a statement is in fact true or false, we can also ask whether a statement is possibly true or possibly false. And similarly with snow is white, that statement is actually true, but it's also possibly false. For it's possible that snow is another color. It could have turned out that snow is, for instance, green and grass is white. That's obviously a crazy possibility, but it's still something that's possible or conceivable. And for that reason, it's possibly false that snow is white, despite that it's actually true. But now, to return to our example of the statement, Al Gore was president of the United States in 2007, that, as we said, is false, but possibly true. However, some statements are not even possibly true. So for instance, consider the statement that my car has traveled faster than the speed of light. That is obviously false, but furthermore, given the laws of physics, it cannot be true because the laws of physics say that nothing can possibly travel faster than the speed of light. Or consider another example, the statement that 2 plus 2 equals 5. Now that's false, but furthermore, given the laws of mathematics, and in particular arithmetic, that statement cannot be true. It's impossible because that statement, 2 plus 2 equals 5, violates the laws of mathematics. And now finally consider the following sentence. Rory, me, weighs 200 pounds and Rory does not weigh 200 pounds. This last sentence is logically impossible. It's utterly impossible for it to be true that both I have this property of weighing 200 pounds and that I do not have that property of weighing 200 pounds. So in addition to some statements not even being possibly true, some statements are not possibly false. That is to say that some statements are not only actually true, but necessarily true. And here are some examples here. And these are kind of flip sides of the examples we just looked at of necessarily false sentences. So consider first, nothing travels faster than the speed of light. So given the laws of physics, this statement has to be true. It's physically necessary, or necessary given the laws of physics. Now, the sentence 2 plus 2 equals 4, that's necessarily true given the laws of mathematics. And now finally consider the following sentence. Either Rory weighs 200 pounds or Rory does not weigh 200 pounds. This final sentence, we will see, has to be true given the laws of logic, because according to logic, as we said it in the assumption we made a few slides earlier, every sentence is either true or false, and never both. So given that, it must be the case that the sentence Rory weighs 200 pounds is true or false. So that means that it has to be true that Rory weighs 200 pounds, or it has to be true that Rory does not weigh 200 pounds. So given the laws of logic, where we make the assumption that every sentence is either true or false and never both, this final sentence here is necessary, is logically necessary. So the concepts of logical possibility and necessity are central concepts of this class. So in addition to whether an argument is valid, i.e. whether the truth of certain premises guarantees as a matter of logic the truth of a conclusion, we can also talk about sentences whose truth is guaranteed as a matter of logic, or whose falsity is guaranteed as a matter of logic. So another way of putting this is that the idea that certain sentences are logically impossible or necessarily false as a matter of logic, or that certain sentences are logically true or necessarily true as a matter of logic. These are notions that our logic that we develop will help us capture. So here are some precise definitions. So we say a statement is necessarily true just in case, as a matter of logic, it must be true. That is, a statement is necessarily true just in case the laws of logic guarantee its truth. So this is the concept of logical truth. And here I introduced different ideas of necessary truth and necessary falsity, which correspond to the laws of physics or the laws of mathematics. And I mentioned these as a way of contrasting them to the notion of necessity that will be the topic of this course, which is logical necessity and logical impossibility, as opposed to mathematical necessity and mathematical impossibility, or physical necessity and physical impossibility. So when we talk about a statement being necessary in this course, what we really care about is whether it's logically necessary. And what that means is that the statement's truth is guaranteed by the laws of logic. And just as we can talk about necessary truth or logical truth, we can also talk about necessary falsehood or logical contradictions or logical falsehoods. And we say that a statement is necessarily false just in case, as a matter of logic, it must be false. That is to say, the statement is necessarily false just in case the laws of logic make it false. So to return to our example here of a logical impossibility, Rory weighs 200 pounds and Rory does not weigh 200 pounds. Because as a matter of logic, we're assuming that every statement has to be either true or false and never both, this sentence can never be true, because in order for this sentence to be true, it would require that a single sentence is both true and false. It would require that it's true that Rory weighs 200 pounds and that Rory does not weigh 200 pounds. But that would require that a single sentence is both true and false. However, that violates our assumption about the laws of logic, which is that every single statement is either true or false and never both. And finally, in addition to necessity, we also have the idea of possibility. So we also say that a statement is contingent just in case it's neither a necessary falsehood nor a necessary truth. So to go return to our examples earlier, the statement snow is white is a contingent statement. The laws of logic do not guarantee that it is true, nor do they guarantee that it is false, despite that it's actually false. That is actually true. And similarly, we have a sentence that's actually false, that Al Gore was president of the United States in 2007. But despite that is actually false, the laws of logic do not either guarantee that it's true, nor do they guarantee that it's false. That is to say that it's possible for this sentence to be true, and it's possible for it to be false. So these sentences are cases of contingent sentences. They're sentences that are neither necessitated to be true nor necessitated to be false by the laws of logic. So in the next video of this lecture, I will talk about some further logical notions. Before turning to that, however, let me quickly work through some more exercises of example statements, and I will discuss which of these three logical concepts they fall under. So we're going to work through some examples and wonder about whether or not these example sentences are necessary truths, necessary falsehoods, or contingent. So as a famous piece of history, the Roman general Caesar took his army and invaded Rome to temporarily take control. And this was an important event which precipitated the end of the Roman Republic and the beginning of the Roman Empire. And there is on the outskirts of Rome a small river called the Rubicon. And when Caesar crossed the Rubicon with his army, that signaled that he was ready to invade Rome and take control. So, given this historical background, consider the statement that Caesar crossed the Rubicon. This statement is true. This was an actual part of our world's history. So again, this statement is a true statement about our world. But now, let's wonder, is it necessarily true? That is, as a matter of the laws of logic, is it necessary that Caesar crossed the Rubicon? Now, hopefully, you can tell that that is not the case, that this is not a logical truth. That is, there's many possible situations you could imagine or different possible ways things could have gone in which Caesar did not cross the Rubicon. So, for instance, suppose that he decided not to try to take control of the Senate. In that case, he would have not crossed the Rubicon. And that is a logical possibility. Similarly, we can ask, is this sentence necessarily false? Well, we know it's not necessarily false because we know that it's in fact true. So we know there's at least some possible ways things could have been in which it's true. So this sentence does not violate the laws of logic. So because this sentence, Caesar crossed the Rubicon, is neither guaranteed by the laws of logic, nor does it violate the laws of logic, we can conclude that this sentence is contingent. The fact that Caesar crossed the Rubicon is a contingent fact about the world we live in. Now consider another example. Someone crossed the Rubicon. So is it a logical truth? Is it a necessary truth that anyone whatsoever crossed the Rubicon? Now, of course, in our world, many more people than just Caesar have crossed the Rubicon. However, it's still not a necessary or logical truth that anyone ever has crossed this river, or any other river. So again, you can imagine a possibility in which this river, the Rubicon, was crossed by no one whatsoever. And so that means that you can imagine a possibility in which it's not true that someone crossed the Rubicon. So that means that the laws of logic alone do not guarantee that it's true that anyone ever crossed this particular river. But in our world, it is true that someone crossed this river, and therefore we know for sure that this sentence is not necessarily false. The truth of this statement, i.e., whether someone whatsoever ever crossed this river, that truth does not violate the laws of logic. So again, this statement that someone crossed the Rubicon is a contingent statement. It's a contingent fact about the world we live in, and its truth or falsity is not determined by the laws of logic alone. And so, as a flip side to the second one, the one we just looked at, consider the following sentence. No one has ever crossed the Rubicon. Now, this sentence is, as a matter of fact, false in our world, because there have been some people who have crossed this river, and Caesar is one of them, for instance. And but despite that this sentence is in fact false, it's also similar to these earlier two sentences in that it's not necessarily false, and it's also not necessarily true. This sentence is not guaranteed to be true or false by the laws of logic. Rather, it's a contingent fact whether or not it's true that no one has ever crossed the Rubicon. Now I want you to consider the following sentence. If Caesar crossed the Rubicon, then someone has. Is this sentence a logical truth, a logical falsehood, or a contingency? Now, hopefully you're able to tell that this sentence here is a logical truth. So this sentence, again, the conditional sentence, if Caesar crossed the Rubicon, then someone has. This sentence does not say that Caesar or anyone else did in fact cross the Rubicon. As we've established, whether or not Caesar did cross or even anyone at all crossed is a contingent fact. But this sentence does not say that, in fact, Caesar did cross or anyone did cross. What this sentence says is that if Caesar crossed, then someone has. And now, hopefully you can see that as a matter of logic. If this person Caesar did cross the Rubicon, then somebody has crossed the Rubicon. So it's impossible to think of a situation in which it's true that Caesar crossed the Rubicon, but it's not true that someone has. Okay, so this sentence here, if Caesar crossed the Rubicon, then someone has. This sentence is a necessary truth or a logical truth. Because as a matter of logic, we know that if this particular person, Caesar, crossed the Rubicon, then in fact, somebody has. Now let's consider the following sentence. Even though Caesar crossed the Rubicon, no one has ever crossed the Rubicon. So in a sense, what this sentence is saying is that it's true that Caesar crossed the Rubicon, and it's also true that no one has ever crossed the Rubicon. Now, is this sentence necessarily true, necessarily false, or contingent? Now, hopefully you can see that this sentence is necessarily false. There's no possible way that things might have been in which Caesar crossed the Rubicon and also no one ever crossed the Rubicon. So again, it's logically impossible for it to be true that this person Caesar crossed the Rubicon, but also no one crossed the Rubicon. So this sentence, again, says that both Caesar crossed and no one crossed. And that sentence is necessarily false. It's a logical contradiction. It's impossible for there to be a case in which the sentence is true. So as a matter of logic, we know that this sentence is false. So these are some examples of sentences which are, on the one hand, contingent. So these first three sentences state contingent facts about our world, or things that are contingently false of our world, as in the case of the third one. The fourth sentence gives us an example of a necessarily true or a logically true sentence. And the final one is the case of a necessarily false sentence or a logical contradiction. So these final two sentences are sentences whose truth or falsity is determined by the laws of logic. And so logic themselves won't tell us whether or not, for instance, this person Caesar crossed the Rubicon. In order to determine whether that is true, we have to do history. But with the tools of formal logic that we develop in this course, in addition to assessing the validity of arguments, we'll also be able to determine whether sentences like these are true or false, based on whether they're based on them being logically true and logically false. So in the next video, I will turn to some other logical notions that our formal system will help us capture.